Welcome to Woodlands Maths videos. I'm going to show you 3 wee examples of National 5 trig identities. So I've tried to prepare this so it's nice and quick. If you have sin 30 and you divide it by cos 30, on your calculator, if you were to do that, you should find that you'll get the surd root 3 over 3. Okay? If I then asked you to work out tan 30 and pop that into your calculator, you will find that you get root 3 over 3 again. So what we can quickly work out is it doesn't matter what value you put in for sin, cos or tan, with those numbers being the same, you will always get the same either side. And that gives us, for National 5, our first trig identity. And that trig identity is sin x over cos x is equal to tan x. And I'll refer to that as trig identity 1. Okay? Second one. This time I'm going to do sin 30 and then square it, cos 30 and then square it. And if you did the same in your calculator, you will get an answer equal to 1. If you do that for sin 45 and cos 45, or any value, you will still get a value of 1. And that gives me trig identity 2. Now, rather than writing sin x in a bracket squared, they get rid of the bracket and they write it like that. So that is my trig identity 2, my TI2. Okay, so let's have a wee game here. And we quite often refer to this as substitutes on a rugby pitch. Somebody's knackered at half time, let's replace them and put on some fresh legs. So that's what we're actually going to do here. Okay? But it's terribly important when you do trig identities, you have to make one side equal the other side. You do not cross that equals. So no crossing the equal sign is absolutely crucial. Okay, I'm going to start you off with example 1. Tan x cos x is equal to sin x. Well, what I tend to do is label the left-hand side and shorten it. There's my left-hand side and there's my right-hand side. And I'm not going to touch my right-hand side. Nothing's allowed to cross that equals. But I'm looking at the left-hand side here. And we're at half-time in the rugby. Somebody is knackered. I need to replace it. Now, if we look at this, which one of those two trig identities looks as if it's going to match up with something here? And I hope you can see tan x, I'm taking off and I'm putting on some fresh legs. And the fresh legs are sin x over cos x. I've still got my cos x there. And I'm trying to get this side here equaling sin x. Okay, so I've taken off tan x, I've replaced it with sin x over cos x. I can see here I've got a fraction and I'm going to make that a fraction as well. And I hope you can see you can cancel out the cos x's, leave 1 in its place, and then we're left with sin x times 1 over 1 equaling sin x. And lo and behold, sin x is equal to sin x. Objective achieved. So my left-hand side is now equal to my right-hand side. And that is me finished as required. Okay, I'm just going to bubble that one off. So what are we going to do in this one? Well, I'm trying to make the left-hand side equal the right-hand side. Which trig identity am I going to use? Well, can you see there? You've got sins, squares and cos squares. Well, lo and behold, we're going to use TI2. What I notice here is, wait a minute, I've got a common factor here. So I'm going to take out a common factor. Pop in here my left-hand side and my right-hand side. And that's going to leave me with sin squared x plus cos squared x. Oh yeah, answer. This is knackered, exhausted at half time. What can I replace it with? Well, my trig identity allows me to replace sin squared x plus cos squared x with number 1. And therefore, I'm getting 5 equal 5. So I've now got my left-hand side equaling my right-hand side, just what the doctor ordered, as required. Okay. I'm going to quickly pop down a wee bit more tricky one, but let's just show you. Cos squared plus cos x plus sin x in a bracket squared. I think it's terribly important. If you get a single bracket squared like that, I think it's so important to rewrite them. Kids regularly forget, and you end up making a wee daft mistake there. Okay, so I hear you saying, wait a minute, you haven't put LHS and RHS. I have now. So let's multiply them out. And I'm going to get cos squared x plus sin x cos x. I've got, again, another sin x cos x. And I've got a sin squared x on the end of that. And I'm trying to get that to equal 2 sin x cos x. Now, only because I'm old and wrinkly and experienced, but I'm going to move the left-hand side around. And I've got a sin squared x. And I've noticed that that and that are the same. So I've got 2 of them. And I'm trying to get that to equal the right-hand side. Now, what have we noticed here? Wait a minute. There's my substitutes bench. What can I change that into? That's number 1. And I've combined those 2 in the earlier line. And I've got 2 sin x cos x. And check that out. I've got exactly the same on the left-hand side as I have on my right-hand side. There you go. 3 wee examples. I hope that will help. All done.